We'll have to send you next Monday, my dear. It's be nice about first period plan next semester. I have to do all this. All right, these should be the two from homework. All right, so if we look on the back side of the paper we were doing yesterday, this should be the first one, I think, at the top. So, what is my activation energy? What did we come up with? From reactants to the top would be 100. So do we agree with Chris?
Yeah.
We should. EA reverse starts at the product, so down here to the top. So what did you get for that? 250 is correct. All right, and they're both kilojoules per mole. All right, delta H would be from the reactants to the products. So reactants are here, products are there. So what'd you get there? 150 for both of them. All right, is the reaction endo or exothermic? So negative. That means the reverse is positive. Everybody okay with that? Okay. The second one. All right, activation energy starts at the reactants and goes to the top. So what did you get? 80. EA reverse products, and it goes to the top. What'd you get? 30. Are we okay with that? Okay, delta H goes from the reactants to the products. So what did you think? I agree. All right, so putting in our signs. Is it endo or is it exo? Endo, so positive. And that means reverse is negative. Are we okay? Yes? Okay, you will see this on a quiz tomorrow. So we're okay with reading these graphs. There are multiple of these questions on the quiz. Yes? Okay. Let's do multiple choice next. Let's see if I can find that one. That was short. That only had like, 11-ish, 13 questions on it, something like that. Okay. Number 1, C. Number 2, D. Number 3, C. 4, D. 5C. 6A. 7C. 8D. 9B. B as in boy. 10D. 11C. 12C. And 13 is A. Can I repeat who? 2. 2 is B as in boy. 10 is D as in dog.
Can you go over a couple?
Sure.
7 first.
7. If a system at equilibrium is subjected to a stress, the equilibrium will be displaced so as to relieve the stress. that is the definition for Le Chatelier's principle. We're going to work with that one again tomorrow when we shift equilibrium with Le Chatelier. But that is just the definition that we wrote down for Le Chatelier. 10, what's the physical change for a liquid of a liquid to a solid by removal of heat? You probably picked freezing without difficulty, but solidification is just another word for also freezing. We don't use it very often, but it means the same thing. Anybody else? Question?
And the question on 11.
11? All right. 11 says the difference between crystalline and amorphous solids. There's two ways you can classify crystalline and amorphous. We talked about that crystalline had a definite geometric pattern and amorphous has a random arrangement. So you could talk about their pattern arrangement would be one. And the other way we talked about them being classified as crystalline melts at one specific temperature, has a definite melting point, and amorphous melts over a range of temperatures. So you can talk about them having different temperatures that they melt at or having different arrangements. So when you look at this particular question, the difference between crystalline and amorphous solids is determined by, given the answer choices, it's the amount of particle arrangement, because crystalline has a fixed geometric pattern and amorphous has a random pattern or arrangement.
The amount must be.
Gotcha. Anybody else? Yay, Ms. Hutchins. Go on in.
One more time, we're gonna pass that history. Okay. Will you see Julia at all today? I just don't want to roll out yet. Julia upstairs.
I see.
Okay. Sorry for her.
You're fine. Anybody else? Question? So everybody's good on this one. All right. The last one that we have to do then is the entropy worksheet. All right. Figuring out if it increased or decreased. See, I don't deliver homework to y'all. All right, so if we look at number one, did it increase or decrease? Increase. Number two, decrease. Number three,
Increase.
all right.
Wait, what number is it?
It's an example we didn't get to. I want to see what you'd say. All right, so you had N2 as a gas, plus you had 3H2 as a gas, and you went to 2NH3 as a gas. All right, so they were all gases. And so you guys said, some of y'all said stay the same. Now, this is an example we didn't have time to get to because I only had like 5 minutes, so I had to squish my time. All right, they're all gases. So you would think that they stayed the same, right? But is the equation created equally? What's different about it? Close.
Wait, what did you say?
Say what you said again.
It has things on the reactant side, one thing on the product side.
Okay. I don't want to do it in terms of two things and one thing.
One has a stronger bond?
Don't think bonds.
One has two elements, the other one's a compound.
Okay. Think about something we would have learned that would be more important to me or to science than elements and compounds.
One's an atom, one's not.
What? Not atoms. You're on the right track.
One's in,
I'm confused.
Think math that we learned.
I don't want.
one has more coefficients.
Okay. What do the coefficients represent?
The amount
What amount?
of
Moles.
Yes. All right. How many moles are on the left?
4.
4. So,
Okay. So if we go from 4 moles to 2 moles, did our entropy increase or decrease? It decreased. All right. So for number 4, what would happen? It increased. Number 5 increased. Number 6. Yep. Number 7 decreased.
Wait, I'm
What
gonna slow down.
is the difference? Is
I'm still trying to change.
What's number 6?
Oh, sorry. I didn't realize we were still stuck on number 3. Number 3, the only thing that is different about 3 is they were all gases. So you had to look at the coefficients. Okay? All of the rest of them that we just ran through, those are all going to look at states. So when you look at 4, you're going from a solid to an aqueous. So what happens if you go from solid to aqueous? Does it increase or decrease? If you go from a solid to an aqueous, it increases. All right? In 5, you go from solid to liquid. So what does it do? It increases. In 6, you go from a solid to a gas. Increases. In 7, you go from aqueous to liquid.
Okay.
It decreases. All right? So in 8, what?
I thought those were like the same thing.
Aqueous and liquid? No. Aqueous and liquid are not the same thing.
It's just between.
Aqueous is between liquid and gas. All right, so in 8, we're going from a solid to a gas. So it does what? It increases. Now, 9 is all gases again. So what do you have to look at? Okay, so how many coefficients are on the left?
2 or 2.
How many are on the right?
2.
So what happens if you got 2 and 2? That's right. Okay, so you could put no change. You could put stay the same, but basically, is the entropy going to change? It's not going to change. There's no effect. All right, number 10. You're going from aqueous to solid. Okay. Number 11. Here you go with all gases again. So what do you look at? The moles. How many on the left? How many on the left?
2.
2. I'm like, where's he seeing 6? On where?
You don't see the arrow in that.
No, on the left side, not the right.
I don't even see 6 on the right.
Because they thought the arrow was in the arrow.
Oh, okay. Okay. There's 2 on the left. And there's how many on the right?
5.
Yeah. There's 2 on the left and there's 5 on the right. So what happens? It increases. All right. And number 12, we have all solids. So what do we do? Coefficients. How many are on the right?
2.
Chris, I'm talking.
Chris, 2 plus
You
3.
can't tell the difference between an arrow and a plus sign?
1.
Number 12.
Okay, and number 12, there are how many coefficients on the left of the arrow? There are 5, and it yields how many on the right?
Oh, no, 2.
So 5 yields 2, and so we would decrease. Worried about y'all these arrows. Number 13, we go from aqueous to liquid, so it decreases. Number 14, they're all gases. You go from 2 to 2, no change. And 15, you go from gas to liquid, so it decreases. All right. Now, hopefully, if they ask you something about entropy, you'll be okay.
Wait, what was
I was until you started having all of them the same.
Oh, say what? 8 is increase.
There's 3.
Now, if they ask you about Gibbs free energy, pick B and move on. Because I'm not doing Gibbs. I don't think they'll ask about it, so I'm opting to skip it.
why did we? Like, is that the?
Ms. White says pick B.
I thought it was
And they
6.
asked
I'm I'm choosing to follow Ms. White's logic.
Really fucking see, like,
Ms. White says pick B. We're going with Ms. White. She seems to know a lot.
Ms. White?
Yeah.
As well.
What?
They asked about what?
Huh?
Yeah.
Gibbs free energy.
She got
That's a topic I'm choosing to skip.
We're supposed to be doing food.
Oh, yeah, we are, aren't we?
Yeah, that's next time.
She looks like
All right. You can either use your phones or a computer. And the card's still unlocked. I forgot to lock it yesterday.
Somebody could stole the laptop.
They could have. I completely forgot it. From first period yesterday.
Which part?
Mr. Daddy having a girlfriend?
No, he's married. No, I thought he was gay. He's married. I thought he was gay too.
This was.
Go to jail or tax.
You know what? Y'all gonna get off. It wasn't even that serious.
No, seriously, was it like for?
It was like, yeah. It's like fraud or something like that.
I mean,
So you have to do business stuff, bro? It's like to our name.
oh, he's the old. Oh, no.
Wait, that's what you got is from Bruce his knee. I said, the hell are you getting together, bro? No, they did, yeah. I remember, that was the same time when I found the legal guy. I think you should go and go back.
I still gotta have it.
I picked up yeah, it was people who's trying to be your card.
Like it's full.
Yeah, I should be up.
Wait.
He was short.
I'm short. Okay, but he was short.
All right, there you go. Come on, quickly, guys.
I'm trying.
Building my phone.
Does making children sad make you happy?
Look, that dude ain't here. He ain't playing.
Did you get to like a certain point where you just didn't like teaching anymore? You had to do it. This all.
Huh?
Did you get to a certain point where like you don't like teaching anymore? You get it so.
I haven't got to that point yet. There are things about it that frustrate me at this point, but it's not as much fun as it used to be. Some of the things about it have changed over the years, but that's more political and things that are required of us than anything. All right. I'm missing two.
This is why I
Should we take like the father and the man?
No.
I need energy.
Is it loading, Chris?
Yeah.
I love it.
All right. Some of these have more time than others. Some of them have graphs. So this is probably a graph question.
No.
See, it's not letting me answer.
Oh, yeah, I got it wrong.
Oh, no. I think I did it right.
It won't show you. See, Miss Wilson, I don't let me answer the question. It's not answer that.
I don't know why. All right. I don't know if it was your phones or what, but it should be exothermic Y. The products are where?
Lower.
The products are lower.
What?
I don't know. Oh.
What?
Yeah, I don't know.
All right. Let's just choose C.
Now, when we talked about kinetics, what did we say would cause the rate to go up? Raising the temperature. So if I say slowest rate, what do we know about temperature? Has to be the lowest
So
temperature.
you mean to tell me you never have to pay attention to the picture?
No.
I didn't.
Really don't care though.
Highest temperature, fastest rate, lowest temperature, lowest rate.
The pictures threw me off.
I'm sorry. You're going to see stuff like that on the
Did
exam.
you make this?
Yes.
You showed them my pictures.
I don't pick general ones. All of mine are homemade.
Why can't you just say endothermic X?
I mean,
I picked the wrong one.
You might even see some of this tomorrow on the quiz.
you have those whole.
Oh, oops, I didn't even answer it.
Oh, they bad?
All right. So to be absorbed, is it endo or exo? All right. To be absorbed, is it endo or exo? It has to be endo. Okay. So keep that in mind. So it's got to be endo. So don't forget that. Now, notice that the question says absorbed. So which two do you know have to be booted out? The two that say release. So the red and the blue have to go because they both say it's released. The question says it's absorbed. So you have to be either the yellowish or the blue color. Now, you have to remember absorbed means what? Positive. That's just gross memorization, and I know that, but you got to learn it. All right, which one is activation energy?
There is no.
There's A, B, C, and D. Which letter represents activation energy? A, B, C, or D? You will see some of these same graphs on the quiz.
Activation.
How many questions is it?
Depends on which one I pick. Either 10 or 11. Probably multiple choice. I have multiple to choose from here. All right.
This was the first one.
All right. So when you look at that graph, activation energy has to go from where to where?
The starting point.
The reactants to where? To the top. So from the reactants to the top puts us at B. Okay. From the reactants are where? Here. To the top is there. So the reactants to the top would be B. What's what? C is nothing. C is way down here on the bottom line. Nothing's down here at C. Whoops. I mean, technically, it would be the activated complex. Have I talked about the activated complex? No. But technically, it would be the activated complex. The activated complex is up there.
What?
Nothing, Chris. We don't want to know.
It's okay.
I guess.
Acid.
There were 10 requirements yesterday for a successful solution. Sufficient kinetic energy and proper orientation. Okay? Good thing we're not doing the quiz today.
Good thing.
That's why sometimes I think y'all get out the laptops.
Look, I've never seen this before.
Oh.
You know, I might as well just not play.
Alright, what factor will increase the rate of a reaction? Increasing the surface area. Remember, you'd have to add a catalyst, you'd have to raise the temperature, and you'd have to increase concentration.
I know this.
That's
I
good.
know this. I think
Alright, that's good. The trouble point.
I have no.
Remember, the critical point and the critical temperature, these two, that's when the liquid can no longer exist.
They're both in the liquid you no longer.
Yes,
Yes.
you become a gas at that point.
Oh.
Solid changes to a liquid.
Oh, we gotta use big words.
Get off, added.
Added.
I'm pretty sure you're not going to see added and give it off on the exam. Well, that's good. We're split half and half. In order to change to a liquid, does the solid have to move faster or does it have to slow down? If it has to move faster, you have to add the heat. That's why it's absorbed. The solid has to go faster. If it has to slow down, it's released. All solids have which of the following?
Oh,
That's cool.
oh, this was just one. Okay.
Some of them were.
Wow.
You may see some of them tomorrow.
Are you serious?
Yeah.
First of all,
You know, on any occasion, I think it's not.
All right. Solids have all the above. So those of you who picked those other answers are right. You just don't have all of it. I couldn't fit it in the question.
We got 30.
I couldn't make it fit.
What's the question?
It's all of it. Yeah, I'll give them to you.
Oh, okay. I mean, I still don't get it. Is this stuff gonna be on the quiz?
It's possible.
I think I get it wrong.
I don't know.
I think I got it right.
I think.
Oh my God.
I was right.
All right. So all it's telling you is you have powdered zinc versus a strip of zinc. So which one is going to react faster? The powdered, because it has more what? Has more surface area. That's all it's saying. It's got more surface area. You know, y'all think questions are stupid if you don't get them right.
Yeah.
I mean, I got it right, but it's just words. It was just on this one.
I got this one.
I hate this one, but that's how it is. Turn off your Wi-Fi.
My Wi-Fi.
You can click it inside.
All right. That was one of the questions that I think Caroline asked when we were going over the answers on the worksheet. That's Le Chatelier's principle. All right, last one.
Thank God.
It's Le Chatelier's principle.
Wait. Oh, don't get in.
All right.
Oh, I read it.
All right. The particles in a solid do what? They move less. Particles in a liquid move more.
Let's play another one.
Nope. We're done with
I
that.
have to make sure I fully understand.
Too bad. We need to move on to equilibrium. All right. You think you should all fail?
That's equilibrium.
No, we need to do chemical equilibrium. We've only done physical equilibrium. Nope.
No, it's not.
I got
Too
like
bad.
12 pages with the word
She does.
equilibrium.
All right. Find your notes. You will need a calculator today, so go ahead and grab one. While those of you are putting up your phones and your computers, grab a calculator.
Okay, so you can grab one for yourself.
Have any?
Me?
I need your pencil.
No, you don't have to grab two.
Right now.
My foot
Oh.
sweat for you. Don't pick it up.
It's not a mess.
It's less work for both of us. Win-win situation.
Give it to somebody else. Just walk over there. Hand it to the next. We all want to go home. We're trapped like rats on a sinking ship. We all want to abandon ship. We can't do that anymore. We might drown.
I would much rather.
You sound like my daughter. I should hook you up. When I remind her it's 5 months until summer break, she just wants to cry.
You know, when I have my grades for school year, I'm gonna.
So what?
I like one break and all that crap. I like summer because it's my birthday. I don't know. I like
No, she doesn't like that. She just likes the idea of the homework.
I mean, summer projects, so it's like. I know, I mean.
Wes didn't give him summer projects, so she doesn't have to worry about that. So they have year-long AP classes, so I don't have to worry about that.
That's where.
No, they have it every day for a year. And they can't take AP classes until they're a junior. At Wes.
See, they're just sort of disconnected.
I agree.
That's really
I wish I would have
cheap.
taken an AP class.
Tell me that people try and talk about it.
I wish I would have taken a second AP class.
I'm glad
So she's forced them to do it 3 at once. Yep, I agree. All right. So we're going to hopscotch through this a little bit. So there are things under the blinds I'm not going to uncover because, quite frankly, we just don't need it and we're trying to move quickly. All right. So we're going to do chemical equilibrium. All right. You got the title? Moving on to that next slide. All right.
Well, I guess I do have the title.
Okay. Right chemical equilibrium. All right. So based on what we've already done, equilibrium is a condition in which the rate of the forward reaction equals the reverse reaction. Okay? Now, again, this applies to both physical and chemical processes. The only thing I've really changed up in the definition that I just wrote here is I stated it in terms of a chemical reaction. I said the rate of the forward reaction equals the reverse reaction. Okay? Because when we did this before the break, we talked about 2 opposing processes. Before break, the 2 opposing processes we used were evaporation and condensation. We're not going to talk about opposing processes today. We are strictly going to focus on chemical equilibrium. So we're going to talk about balanced equations. So we're going to talk about a forward reaction and a reverse reaction. In order to have equilibrium, the 2 rates have to be what? Equal. And you have to have 2 opposing processes. So you have to have a forward reaction and you have to have a reverse reaction. So in order to reach equilibrium, those 2 things have to be equal because you still have to have both parts. You can't have equilibrium unless both parts are there, forward and reverse, and they have to equal each other. All right, we caught up? Not waiting on anybody. I hear a no out there. All right. Now, in order for us to write chemical equilibrium, all you need is the arrows. You don't have to write the equation. All right? The reversible arrows, okay, implies equilibrium. All you need, what's in the circle. Okay? So for the most part, I remember to write the reversible arrows. However, sometimes I forget, so if I forget, just remind me and I'll write the reversible arrows. Now, that means that the reaction is reversible to have those double arrows. Everybody got it? The only right one's in the circle. Now, we're going to learn to write what's called an equilibrium constant today. Okay? The nice thing about writing an equilibrium constant is it doesn't matter how much of any reactant or product you start with. Okay? The amounts are irrelevant. Okay? Equilibrium can be achieved. Now, don't write what's under the blind. I need to see. Nope, we don't need what's under it. I only need what's above it. Okay, so we're going to write an equilibrium constant today. And the nice thing about this is it does not matter how much of any reactant or product we start with, equilibrium can be achieved. Okay? So you can have more reactant, you can have more product. If you think back, so when we were talking about the water and the vapor, now sometimes we have more vapor or we have more water, same concept. Doesn't matter how much of either you have. Okay? You can still get to equilibrium. The amounts are irrelevant. All right, don't write for a second. Let me see what's on the next screen. Everybody there? Yeah, we need all of that. All right, first of all, K is unitless. All right, which is nice for those of you who always struggle with units. You will not have to write a unit on K. K is only a number. Okay, it's like pH, it has no number. All right, the capital K that we're going to use is known as the equilibrium constant. Sometimes people ask me, are we going to get that confused with kelvins? No, because K is at the end of the number. Okay? When we write it as kelvins, we always write 273 K. When we write it as an equilibrium constant, we write K equals, let's just say 175. Okay? That's when it's equal to the equilibrium constant. This is temperature. This is the equilibrium constant. Okay? We write it in two different ways. Now, K does not depend on concentration at all. Completely irrelevant. However, K is dependent on temperature. It changes with temperature. The nice part about being in a first year class is you guys do not have to know the rules for how temperature affects K. You only have to know that it does affect K. If you were taking an AP level class, you would have to know how it affects it. Okay? So you don't have to do that. You would have to know whether it's endo or exothermic and whether temperature made it go up or down, but you don't have to. You just need to know that temperature affects the equilibrium constant. That's all you have to know. Any questions on the difference between how we write K with temperature? Everybody okay with recognizing K equals as the equilibrium constant? Okay. Everybody good? All right, let me see what I've got. Don't write yet. Oh yeah, these are the rules. All right, so this is a generic equation that I wrote. All right, the little a, that represents a coefficient. That's a compound. That's a state. That's a coefficient. That's a compound. That's a state. Coefficient, compound, state. You got it? Okay. Yep.
We write the AM.
Mm-hmm. Yep, because that's the example I'm going to use. Now, writing K is one of the easiest things that we do. Step one is the one that people forget all the time. No, I'm going to do it at the end. You don't have to leave space. After we talk about the steps. All right, so step one. To write K, it's always the products over the reactants. Now, I realize that this is a reversible arrow. However, these are always the products. These are always the reactants. Okay? It doesn't matter that they're reversible arrows, and you guys could argue that the arrows can be reversed and either side could be the reactants or the products. The right side are still the products. The left side is still the reactants. That does not change. Okay, products over reactants. Now, that step is usually the step that most people mess up on. And I can guarantee you in your FOIL or wrong answers, they will have that flipped, at least in one, if not two of the wrong answers. Now, step two. All coefficients become exponents. All right, so when you balance your equation, the coefficients will become exponents. So if you have a 2 or a 3, those numbers become your exponents. And the last step. Only certain states are included. Okay? Only states that are gases and aqueous are included. Gases and aqueous are included. Okay? Solids and liquids are constant. Their concentrations don't change. And therefore, we mark them out. All right, we have the steps. All right, so in the fake equation I wrote above, what are my products?
COG plus EG.
All right, well, just the products are O and P, right? So O and P, and we put brackets around them. Brackets just mean concentration. All right, what are my reactants?
M&M.
M and N. And we're going to do this with real compounds in a minute if the fake compounds bother you. All right, and it's equal to K because K is the equilibrium constant. All right, what are my coefficients? My coefficients are the little letters in front of it. So what's my coefficient in front of O? All right, so C is a coefficient. What's the coefficient in front of P? All right, what's my coefficient in front of M?
A.
And my coefficient in front of N.
B.
Now, if any of these are liquids or solids, I mark them out. Are any of them liquids or solids?
No.
Then they all stay. Okay? And that's how you write an equilibrium constant expression. That's it.
We don't have to solve for it.
If we had numbers, we'd put them in, which we're going to do shortly. Right now, we're just writing the K. But it literally is that easy.
It looks so.
The only catch is if there's a solid or a liquid, we're going to mark them out and erase them. If there's a number, we put the numbers in. And we just divide and multiply.
Okay. Simplify it so it'll be like a single number.
Well, like if this one was a liquid, for example, we cross it out and take it out. Or if P was a solid, we'd cross it out and take it out.
No, but like you said, if they're actual numbers.
Then we'd plug in the number in the spots and we'd multiply them or divide them.
But I thought you said they'd be compounds.
Yeah, well, these are compounds, but I'd give you the numbers for the compounds and say the concentration is like 0.25. The concentration of this is 0.15. So you'd plug in the numbers for them. So you'd multiply them and then divide. I'm going to give you numbers for all the compounds. For the most part, the hardest part about doing this is actually once you plug in the numbers using the calculator. That's the hardest part for most people. All right. So let's say, what do I have there? I don't need that. All right. So let's say we want to write the expression for number 1. Okay. So K equals. What is my product in number 1?
Oh.
O what? Okay, so O2 goes on top over what is my reactant in number 1? Okay, over O3. All right, that's the first step. Reactants over products over reactants. Now, step 2, coefficients become exponents. So, looking at the equation, do I have coefficients in number 1?
Yes.
Okay, so I need to make exponents. So what's my coefficient in front of O2?
3.
So I'm going to put a 3 there. What's my coefficient in front of O3?
2.
Now, are either of them liquids or solids?
No.
Then they stay. I don't mark either of them out. Are you with me?
Yes.
Okay. If I do the bottom one. All right. What are my products? Okay. Ca, CO3 over what are my reactants? CaO and CO2. All right. Do I have any coefficients?
No.
So this time, will I have any exponents?
No.
No. Okay. So This time, do I have anything that's a solid or a liquid? Yeah, I got solids, right? So what's a solid this time? So CaCO3 is canceling out, and CaO is canceling out. All right, so I'm in math class, right? Okay, equals. What do I put on the top if my compound canceled out and there's nothing left?
1.
That's right. I just put 1 there. Okay. CaO went away, and what's left on the bottom? All right, 1 over and CO2. And that's what I have left because the top half canceled out. You still with me?
Yeah.
That's as tricky as it gets.
Okay, can you like?
Yep. But I wouldn't have called that tricky because you guys are all in like math 3, even if it's next semester, before you tell me that again. Now we just have to put some numbers in.
No, thank you.
It's not optional.
We can leave it just how it is.
I'd like to practice in case you have to see it on the exam. I mean, they may not give you numbers. They may just ask you to write K. They may not ask you anything about K. I don't know. I will be surprised if you don't see anything about K or shifting K.
They don't even give you like the percent standards for how many of each subject.
No.
Why? That's so stupid.
I just get the overall goal in this section, but I don't know how many go with each sub-goal. I know. That's all I know.
Like, how much do we actually have left? Like, we're not gonna get to the top.
I'm going to hit, once we finish this, I'm going to hit molarity and dilution, and I'm going to hit the highlights of nuclear. We're not going to hit titrations and acid-base pH stuff. Will be about it. Yeah.
So you're
Say what?
the thing that you
The thing that I just said?
no, the like little clip thingy. Can I come late?
Like how late?
Okay, so they decided to do talent show practice day. The director said it's fine if I come late, but I was really going like first, but I don't know what time I'm gonna start. So it'll probably be for 4.
That's fine.
Okay.
You said there's like.
So since the talent show is tomorrow, what time do we get out of here? Like 9 o'clock?
No, I don't know. They just sent the schedule. My best guess is maybe 9:10, 9:20. I don't know. I can look.
I see.
Do we write all of that?
Yeah, it looks like it's a lot. It's just spaced out.
That is a lot.
Just write it down. I'm wanted. I saw the email from Miss Henson pop up with the bill schedule. There it is. 9:30. So an hour and 10 minutes.
What time do we do third period?
You leave third period. You get there at 11:05, and you leave at. Looks like the end of third lunch is 12:55.
Second lunch?
Second lunch is 11:45 to 12:15.
Okay, so
Fourth period is only an hour.
okay, so I'm gonna
1 to 2. And then the talent show is 2:30. So if you're not going to the talent show, you're in fourth period from 1 to 3:30. Okay.
Is the like tutoring thing only today?
It's today and because I told you there'd be 3 opportunities, so you had the potential to earn
Oh my God.
2 points.
This is a lot.
Will they always write it like if it's a gas or something?
Hmm.
Will they always write it if it's a gas?
Yes, they will.
Will they ever have the unit different?
Say what now?
Will they ever have two units on
The unit can be either moles per liter or molarity. They could also give you atmosphere, but I don't think it will. No. I really think it'll say moles per liter. Molarity I'm going to do next week. Like I said, I'm trying to hopscotch around and hit the high value targets. This shifting tomorrow, which we were not going to get to until Monday because of the short class period and the talent show. It'll be Monday. I'm going to do the molarity and dilution stuff. And then I'm going to try to hit some nuclear, because nuclear is so easy. If I can hit the highlights, you'll be able to get nuclear questions right. Malaria and dilution, you'll be able to get right. The shifting is the hardest thing we have left. But I think you'll see that. So nuclear, malaria and dilution, and chemical equilibrium shifting are the three things that I really think you are likely to see. Now, in the after-school tutorial, if you want me to hit some things with pH, with the equations that are in your reference table, if you want me to do some of that after school next week, I'll be glad to do that. I mean, I tutored my own daughter, and she managed to score 94 on the exam and test, so clearly I can manage to do some things with the tutorial.
So what percentage?
Did you finish
I feel bad for you as well.
Why?
Because he was in one period, in one team.
No, I paid for all those suckers to go.
Are you kidding? You paid for them to go?
I only actually had to pay for one, the rest of them managed to pay. There are two who told me they were not going to be there, and I need to confirm with them today whether they're planning to be here tomorrow or not, but they will not be spending 2.5 hours with me. I will pay first.
It's nice to know that you hate them.
There is no way
That you
I'm
actually
spending
are.
2.5 hours.
What do they do? Like, are they just like?
They just don't.
Just don't do anything.
That doesn't sound right.
There
What
are,
if your fourth
like-
period still gets moved?
there are, let's say, 12 people who work very well.
How
And
many?
there are 7 people who have averages that are 20,
How many are in here?
19 on them, not counting the 2 that are permanently ejected.
Yeah, you better not.
What's almost over? Dude.
Amen.
Right.
I'm still waiting for it to happen.
No what?
You said flips forward.
It was like measuring there.
That should be sufficient. All right, so we've got a cup written down. So let's write K. All right, you always start by writing K equals, first of all. K has to be there. So what are my products? All right, so the H2O. And what else is a product? Cl2. And over, what are my reactants? HCl.
So if we don't,
And O2.
if we don't put the little brackets, when you say that?
Well, the little brackets just represent concentration. Okay, am I going to take off for it? No. Now, if I ask you to write the K expression, yes. Now, if you're calculating like you're doing here, no. But if this was a large quiz question and it was free response and I was giving you partial credit, yes. So I would write them.
What if I accidentally put a parentheses?
Parentheses are fine. I'm not going to take off if you write parentheses. All right. Do I have any coefficients that need to become exponents?
Yes.
Yes. So I need to put a what on water?
Oh. 2.
And on chlorine?
2.
And on the HCl? And on the oxygen?
1.
It's 1, so we're not going to write anything. Are any of them solids or liquids that need to be marked out? No. All right. So that's all. Now, to calculate.
You said that was all.
That's all for writing the expression. Now, we have to determine the constant. So how do we determine the constant? That's the expression.
I'm confused.
Let's just skip the constant.
So do you take the numbers?
Now we're going to take the numbers and we're going to plug them in.
Haven't you done simple or non?
I already plugged the numbers.
But that's a lot.
Like 2.
It's not that hard, people.
You could have done. Oh my God.
So, what's the number for water? You look up here and find water in your question. 5.8 times 10 to the negative second. So 5.8 times 10 to the negative second.
That's a lot.
And we're going to square it.
I thought we were
Wait,
supposed
what?
to do something with the.
Why are we going to square it? Because there's a square right here on the water. Okay? Now we're going to do chlorine. Chlorine's number is the same number. 5.8 times 10 to the negative second. And chlorine also has a what right here? It has a squared on it. So we're going to square it. All right. Over HCl, we find that number. HCl has 1.2 times 10 to the negative 3. And HCl has what number on it? Do you have any more kids?
No.
Oh.
This one needs to go to the cafeteria at the end of the period.
Are you kidding? I haven't seen him this entire quarter.
Then you can't send him.
I can't send him. The only time I saw him was the day we were on the lockdown and he showed up for second period and they made him come here. You're welcome. If I by chance see him today, I'll send him.
Wait, the one that sits there.
Yeah.
Louis?
Louis.
Which is it?
Luis. I just called him Lewis because, y'all didn't tell me his name was Luis at the beginning of the
Okay,
semester.
How is his name spelled?
It's his fault.
Not my name.
How is his name spelled?
L-U-I-S.
And you said Louis?
Louis is spelled L-O.
L-E-W-I-S, right? Oh my God.
Yeah.
Please stop.
I'm
You're
thinking
spelling
Louis is Louise.
Come on. I'm an old white lady. Give me a break here. Y'all could have helped me out. Y'all been in school with that boy for how long?
Okay.
And y'all knew I was saying his name wrong.
Wait. How many times did I say it back here?
She did.
She said it.
And Diamond couldn't say it loud enough to say Ms. Wall.
Well,
How many years have you been teaching? I'm sure you have
Louis.
You have
Louis.
I can't say maybe. Anyways, what number goes on this? So we got to put a 4 on there. All right. Now, the last one, O2, find its number. And we have 3.8. And it does not get an exponent.
Okay.
Now, this is why I said a minute ago, for most people, the hardest part about this is doing what? Punching it in the calculator. Okay?
We're not done.
All you got to do is put it in the calculator.
Wait.
You actually is
How do you even? Come on now.
This is good.
It's too early.
So 5.8 second EE. Right? You don't hit times 10. Second EE.
Okay, I've got a question.
Negative 2.
I'm always worried to mess this up.
Square.
You want a negative sign, you press the
Yes, you push the negative sign, not the minus. All right, and then times 5.8 second EE.
Wait.
But now you have to square, right?
Negative 2, and then square that one.
Does it have to
Can we put this in parentheses?
I don't put it in the brackets. I don't use parentheses on any of the top.
Wait, can you please? Hold on.
So wait.
All right.
I need to put it.
Clear your calculator.
Weird, man.
5.8
Wait. Oh my God, what is
So you're risky long good.
Then you keep going, you're good.
But
But you don't have to use brackets. We're just multiplying two numbers on the top. So 5.8, second EE, -2. And then hit your squared key.
Okay.
Over there beside the column, above the log.
Right.
I'm not pretty sure it's not.
Wait, can't you do the little carrot thing and then
Why would
You
you put
can.
extra work though?
Times 5.8, second EE, -2, hit squared again. Now, I hit equals before I go on.
Wouldn't it be so much simpler?
Can you just multiply the number?
Oh, you can.
73.817.
What the?
What?
I'm pretty sure it's gonna be a times 10 to the 10.
Yeah, it's time to the -5, right?
Yeah. Divide.
Oh my God. See this?
Now we're gonna divide by what's on the bottom.
I don't.
You use
I don't
here.
know.
Alright,
Oh, I pressed the button.
1.2,
I did this say go to, they say,
I got
second EE,
1.4.
-3. Now this time we gotta use the carrot key. We don't have an exponent to the 4th. So raise to the 4th.
I got 1.44 times 10 to the 10th.
Times 10 to the 10th is the right
do
answer.
you hit enter or do you multiply by the other number?
I'm not gonna multiply, I'm gonna say divide again. Both those numbers are in the denominator. So I'm gonna say divide.
Wait, what?
You know the
You're confusing.
Both of these numbers are in the denominator. Divide, divide. I'm not using parentheses. I'm not saying times that number. They're both in the denominator. This is how I avoid using brackets and parentheses constantly. So hit divide again. 3.8. Second EE, -4. And when you finish that, you should have an answer somewhere in the ballpark of 1.4 times 10 to the 10th. Now, you can do it with 8 zillion parentheses and brackets if you want to.
I know.
It's just a whole lot of extra keystrokes. What's wrong, Elijah?
I think
That's not doing it.
it's an error.
5.8 second E -2
Oh, yeah.
squared times 5.8 second E -2 squared.
Is that what it says there when it says?
It says -2 in the
Yes.
parentheses. That's the exponent. You're squaring what's outside.
That is what the
Divided by.
that you're looking at
Oh, I was
Second -3 raised to the 4th.
Welcome back.
You're
Thanks.
not keeping it raised to the 4th power.
Thank you.
Divided by
It's belated.
3.8.
It's so
Second
not-
E
Negative eight are on the board. Late.
like late.
Yeah, but like, why you put a button? Happy belated birthday.
Happy late birthday. Like,
Alright.
7.E10.
Anybody else? Anybody come show it to them on their calculator?
No.
No.
Hey.
You sure? I just did it for Almaj and actually just pissed.
Does it have a unit or anything on it?
No, K is unitless.
Like, okay.
I do that same thing.
It's
It comes
K.
up here.
It's K equals, and there's no unit on the number. It has no number.
Yeah, you come up here.
It's swap.
What?
So you want to tell me, do you know? Okay. So.
See how you said times right there? That's where you went wrong. That should say divide. Those are both in the denominator. So that has to say, you said divide this, took that answer, all of that divided, and then it multiplied by that last answer. That has to say divide. That's where you went wrong. If you want to do that, you need another set of brackets in there, because it's messing up the order of operations.
Oh my God, I gotta go to class right now.
think I wrote her list right. I'm just serving.
Divide.
Boy, that's how you first of all, did you know? You know? I'll tell you later.
Divide.
She almost. It wasn't really.
Okay, cool.
Okay. Anybody else? All right. I'm going to give you practice with calculating tonight.
No, you're not.
Yes, I am.
You're not.
We don't need that.
How much practice?
All right. Like 5 questions.
That's a lot.
They're shorter than that one. Stop whining.
And then
Now.
a lot.
We need to talk about what K means.
No, we don't.
Yeah, we do.
We already know.
Right. Yeah. Now, K can be 3 things. K can be much greater than 1. When you use 2 greater than signs, okay? K with 2 greater than signs means much greater than 1. Okay? K with 2 less than signs means much less than 1. Okay? Now, if K is much greater than 1, it means the reaction is favored in the forward direction. Lots of products are produced, meaning you have very little reactants.
Wait. Are we talking about like anything kind of bracket so that doesn't sound really stupid?
It's okay, I can work with stupid.
Okay, so are we talking about like, okay, K being, it says much greater than 1. Like what's much greater? You know what, sir?
Like 50 or better?
What?
What?
I was thinking like 10.
Thinking like
Okay, but 50 still greater than 1.
I was thinking like 2.
So I'm confused.
No, 2 would be K is approximately equal to 1. I'm even going 10 is approximately equal to 1.
See, yeah, okay, but I'm gonna ask
Well,
you
then
like
why
this.
class literally makes me
Wait.
I do not like this.
So technically, in the situation that we just had, like, with, the number we just found, that's much greater than 1, isn't it?
Yes.
Okay.
Yeah, it was a times 10 to the 10.
Yeah.
That's got a whole lot of zeros behind it.
The digit notation just kind of goes over
Yeah.
my head.
So that would be a K is much greater than 1.
Okay. There we go.
Yeah.
Is that why there's so many unis?
When do I get to fill out a report on basketball players again? When do I get to fill out a report on y'all again?
We just got one yesterday.
Yeah, just that one yesterday.
When? Today? Today's Thursday.
No.
Yes, Thursday.
Yeah.
Really? I'll just store up my comments then.
Oh, never mind. I mean, I don't have it right now.
I don't even know what they.
You just said you got it yesterday.
But I don't have it with me. It's not-
Oh.
Because I didn't find
He's reachable by email.
Wow, he told me. I said, look at the second on the last day.
So I should just email him and tell him you can't be quiet in class.
Why are you trying to ruin their lives right now?
Because it out people.
It's not multitasking, it's called switch tasking according to Miss Love.
This one is aggravating.
Oh,
You can't multitask. It's not possible. I'm losing my brain.
No money in teaching, I just need perks, and annoying teenagers is a perk. Making their lives miserable. They just working with Ollie.
You remind me of this guy named Nathan at my job.
Why would I do that?
That can't be that fun for you.
You'd be
That
surprised.
constant irritation. I don't know, man. I like. My nephew, I think I'm pretty fun. I like to like my nephew. No, did my sister upset?
I am so sorry. I think I should have done y'all before the break. Did she like it?
You know, they like how we were like this last week. I didn't know how to spell equilibrium, and now I'm like,
Just.
I can do it.
She doesn't want to stop talking.
All right, we caught up?
No, I'm still.
Come on, people.
I'll be the right away.
No, because I'm going over that.
She would be the child.
What's illegal?
That's not my sister.
You're not illegal.
You're not illegal. $9 an hour. So you wasn't born in North Carolina?
My yeah. But you're a citizen.
It's okay.
As long as you have it.
Just don't tell Trump. He might build a fence around him.
What's the last election really 10 years ago? Or 3 years ago? Oh my God.
Oh, no, it's not bad.
We just got
Isn't
1 year
it-
left.
Man, no.
Isn't his last year president?
Yeah. Yeah, because he was inaugurated in 2017.
That's
He was elected in 2016, so he was inaugurated in January 2017.
Wait, so when?
The next election is 2020.
I get to vote.
So like, I'm already registered, I make that.
He can do, you
Don't
know.
have fun.
He can make.
I will.
Yes.
So we caught up?
Oh my God.
Don't worry, the government probably won't even be real.
I'm being so serious. I'm being so serious.
Alright, so if we look at what we wrote down, we need to understand what it means. Because right now, even though it's written in your notes, most of you could not answer a question correctly with it. Alright, yeah. I know.
Right now, to go to 13th grade.
Only partially.
Yes, we
You can still
do.
go to the parks
No,
and
because I.
If he admits it over the summer.
Wait, what?
We come back and sing.
what are you
We'll have to stay
Most
again
of
if
the
he's seniors
public
again.
parks are still
Because he's gonna
open.
be 13th
Some of them
grade.
have closed for sanitation
I'm
reasons.
being so
Because,
serious.
like Rocky Mountain National Park, Great Smoky Mountain National Park, all of those are still open, but the park rangers aren't working. They
Yes,
closed
we
a lot of
can.
bathrooms, so people are just using the fields around it, leaving toilet paper. and things
You just said
everywhere.
it out of context. Why? What are you doing? I mean.
Because
No,
President
it's
Trump
so
said the
serious.
parks could remain open, but the park rangers aren't being paid, so they're not working.
I mean,
that sounds
legit.
The government is shut down because
Over the wall.
it is. Government is shut down because President Trump wants the wall funded, and the government can't agree on how to fund it. Yes. They can't agree on, the reason is they can't agree on a budget. It's not just about the walls. They can't agree on a budget. So until the budget is approved, the government is shut down. But the major sticking point is on national security.
Wait,
The sticking point for President Trump is the wall, or at least that's the part that's making the news. Until the House and the Senate can agree on a budget that the president will sign. Yeah, UPS, the mail service is run. It's only a partial shutdown. It's not an entire government shutdown. So they can't agree on the budget, which is why the government is partially shut down. It's been 12 days. It happened before Christmas.
before Christmas.
Y'all need to tune in to the news a little bit.
I'm so good.
I just learned that.
So there's someone in the vicinity of 800,000 workers who are furloughed who are not getting paid.
They were all like, yeah, you're late, like, I'm so sorry, like.
Yeah, but it's just simply about national security. But the headlines are about he can't have his wall. All right. Now, you don't have to write this, okay? Let's just talk about it.
So are we done writing notes?
Well, we're going to talk about what this means. Now, this is to explain what you just wrote down. All right, so let's say that we have this equation right here, okay? This is our equation. This is what our K is. What can you tell me about this K if you have an exponent of times 10 to the negative 30? Is it much greater than 1 or much less than 1?
Much less than.
Okay, it's much less than 1. Shh. Guys, don't make me keep you after the bell. We do have grab and go. Lolly, sit down, or we'll all be staying after the bell.
First of all, it would really be
Now, when we look at this, if you guys can tell me that K is much less than 1, looking at this equation, whoops, wrong direction. What would we have more of? Would we have more reactants or more products based on what we just wrote down? You just said K was less than 1. You're going to have more reactants. So what would we have more of? Would we have more N2 and O2 or would we have more NO? What are the reactants? You would have more N2 and O2 because you just said that we would have more reactants. We would have less of this because you said this was less than 1. Now, if you had what we had in the question we just calculated, if you had K was 1.4 times 10 to the 10th, what could you tell me about this K?
It's more than 1.
It's more than 1. It's much greater than 1. So what would we have lots of in this equation if this was our K? We'd have lots of products. We'd have lots of NO and very little N2 and O2. Does that make a little bit of sense? All right. Let me talk about homework.
No.
Don't lie.
I wasn't. Just say no. She's in Atlanta.
All right. You're only doing this side. Okay? This goes with shifting Le Chatelier, and we're not there yet. Okay? You're doing 1 through 5. Now, you're calculating K, and I want you to tell me what K means. Is K much greater than 1? Is K much less than 1?
And we only do the
You got to interpret. There's only 5 questions.
So we only do the
We're doing
odd
5.
numbers.
Calculate K into what?
Tell me what K means. Is K much greater than 1? Or is K much less than 1?
Wait.
Did I actually count 3 this time?
Wait.
What? So when you count, you go write K, you calculate K, you go tell me what K means.
Okay, this is fucking drop me. This much less, and then this is much less.
I'm really mad.
How do you teach me
You gotta calculate first. You gotta, you know how we calculate
I'm not
the
even
equation, you
like
gotta do that first.
like, they said it gotta be like.
He just told us yesterday. You talking about some, you already started learning this.
Give it your best guess based on what we know.
Wait, Miss Wall, what is this?
They
The quiz is on like the Kahoot books. The quiz is like the Kahoot. It's not on this stuff.
So
Okay.
it's difficult.
So the quiz is like the Kahoot, like reading potential energy diagrams, boiling, phase diagrams, solids, liquids, gases.
Is it on equilibrium?
No. Well, I mean, it might have something like on physical equilibrium, but it will not be on this. No. No. And if you want blitz, I'll be here this afternoon.